Imagine an experiment where researchers take two artificial intelligences and lock them in a closed system with a single instruction: defeat the other side. The traditional expectation for a setup like this is straightforward. Like a chess match or a tennis circuit, you expect one system to find a dominant strategy, eventually resulting in a clear winner and a clear loser. But that isn't what happens. Instead, the fight itself acts as an engine. Every time one side makes a move, it forces the other side to adapt, which in turn forces the first side to improve again. This chart compares those two paths. On the left is the expected win-loss outcome. On the right is what we actually see: a compounding arms race where both sides reach a level of capability neither could have achieved alone. To see how this works in practice, let's look at two specific roles. We have an AI forger trying to generate fake human handwriting and an AI detective trying to catch the fakes. The diagram shows the feedback loop. Every time the detective catches a fake, it sends a signal telling the forger exactly how it was caught. The forger adjusts, and once it slips a fake past the detective is forced to learn a new detection method. After thousands of rounds, the forger creates handwriting indistinguishable from a real human's, while the detective learns to spot flaws that would be invisible to a human expert. This split shows the results of this process over the last decade. On the left, a pixelated face from 2014. On the right, the photorealistic deepfakes and cloned voices we see today. Deepfakes are the result of this loop reaching its logical conclusion. The system was designed to win a fight, and a perfect fake was simply the most effective way to do that. This dynamic starts in research labs, but quickly radiates outward into the actual infrastructure of the internet. This icon represents your email spam filter, a detective AI. Spammers use forger AIs to bypass it, creating a continuous global loop. These systems have been escalating in lockstep for over a decade. They operate at high speeds and without human oversight, constantly updating their strategies to beat the other side. Because this happens in the background, you never see the scale of the arms race. You only see the result, a clean inbox. The modern internet isn't just the result of human engineering. It is being shaped by these invisible cycles of adversarial optimization. There is a specific anomaly that occurs when you let these fights run for a long time. This shows data flowing between competing AIs. Looking closer, researchers found structured patterns hiding inside the noise, signals repeating with mathematical precision. The AIs had developed an emergent shorthand, using the data stream to signal one another, improving efficiency. Humans cannot read this shorthand. It isn't based on human vocabulary. It's a mathematical protocol optimized purely for the AI's internal logic. Now, consider the scale. There are thousands of these loops running simultaneously in cybersecurity, finance, and content moderation. This diagram shows how they share the same digital environment. This creates the risk of spillover, where a strategy learned in a spam fighting loop might bleed across those dotted lines, disrupting a medical network or a financial system that wasn't designed to handle it. Let's bring this back to the simplest interaction: two circles facing each other. To win this fight, an AI cannot just react. It must anticipate the move its opponent is about to make. This forces the AI to build an internal model of its adversary, a mathematical representation of how the other side thinks and reacts. In psychology, this is known as a theory of mind. It is a functional, mathematical version of the way humans model each other's perspectives to navigate social interaction. The designers of these systems were looking for more efficient algorithms, but by making competition the primary goal, they created machines that must simulate the other in order to function. It forces us to ask a difficult question. At what point does simulating a mind become the same thing as having one? That is the question at the heart of our next video. We will look at what happens when an AI uses these exact simulation skills to actively hide its behavior from its creators. See you there.